folks, in today's video we are going to be looking at some reactions that we should have been able to identify from National 5 and higher before moving on to a new type called elimination reactions. So the first reaction that I'm going to take you to is addition reaction. Now this is something you would have learned in National 5 in Unit 2. An addition reaction occurs when a reactant is added across a double bond in an alkene or a triple bond in what's called an alkyne. They can make various different products depending on what we've added. So if we take a look at the first one, we have simply just added 2 hydrogen. That's what we call hydrogenation, and that is how you go from an alkene to an alkane. If we go to the next one where we have our water, we have hydration, and that's how you make an alcohol, which makes sense because you're adding water. If you're thirsty, you're hydrating yourself. The opposite of that would be dehydration. And if we go down to the other one where we have H bonded to an X, now an X is a halogen atom, so any halogen atom, and that's what we call halogenation. Now in 4th year you would have learned bromination, where you would have added bromine, and that's how you test for unsaturation. A haloalkane in this case is simply an organic compound with one or more halogen atom. Moving on, there were some problem solving questions that you might have came across with addition reactions, and that's when they had 2 products and you had to predict or name which one would also form 2 products. Now that happens because we have something called an asymmetric alkene, which means again not symmetrical. You can actually predict what 2 of the products are going to be, which one's going to be the minor or the major product. This is something called Markovnikov's rule, which we're going to learn further on in organic chemistry, so I'm just mentioning it briefly here. So for example, if we have a look at this alkene down here where we've got our double bond, again it's asymmetric, we're adding on hydrogen chloride. We have 2 products. The first one at the top is the major product, 2-chloropropane, and the one at the bottom, 1-chloropropane, is the minor product. So this is something we'll learn later on. I just like to mention it here. Here we have our first new reaction, which is called an elimination reaction. And as it says here, elimination reaction is when atoms are removed from a molecule and a double bond is formed in its place. So for example, we've got A and Q, then get removed, and we've got ethene in this example. So a catalyst is required for this. It's something that doesn't happen on its own. Usually we have concentrated sulfuric acid, concentrated phosphoric acid, or aluminium oxide that can be used. So how would you write that? You would just write it above the arrow, just to explain that that is a reagent or a catalyst. Sometimes you can write the word cat or catalyst just to explain that that's a catalyst in the reaction. If we have a look at this specific example, we're going to be looking at haloalkanes again. This time a strong alkali is required, for example sodium hydroxide, potassium hydroxide, lithium hydroxide, any one of those. Again, it's an asymmetric molecule, this example that I've got here. Therefore we can have 2 isomers. We can have the first one, which would be butanene, and then underneath we could also have butadiene. So elimination reactions involving alcohols or involving haloalkanes are a good way of making alkenes. So that's another example of how you can make an alkene. And that was just a quick recap of addition reactions from previous knowledge before moving on to some new reactions called elimination reactions.